everyone, it's time for calculus. Today we are finishing our fourth unit. So today we're going to be working with tables and theorems. So the first thing that we're going to be doing is we're going to analyze functions, increasing, decreasing, f prime, f double prime using tables. So we've analyzed functions using graphs and using formulas. Now we're going to be given a table for a function and analyze that. So we'll see what we can determine based on the tables that we have. Then you also see what the intermediate value theorem is and how you can use it, and the mean value theorem and how you can use it. So let's get started. So one thing that you'll need to remember, our beloved chart that we've been using all unit. And the other thing to remember, since we don't have a graph, it's really hard to look at increasing and decreasing and positive and negative, and we don't have a formula. So the other thing to remember is that the derivative is the slope of a tangent line. And let me take you way, way, way back because we're going to rely heavily on this slope definition. So slope, that slope formula, we're going to use that a lot today. The slope formula is y2 minus y1 over x2 minus x1. Because when you don't have a graph and when you don't have a formula, the best way to estimate slope is, or the best way to estimate the derivative is to use this slope formula. So let's look at our first example. So here we have given selected values of the twice differentiable function f. So twice differentiable just means that you can take the derivative twice. You can find it f prime and f double prime. Which of the following choices could possibly be true for the entire domain? And then I notice I've got to determine the sign. So I have to figure out if f prime is going to be positive or negative. Then I have to determine if f double prime is going to be positive or negative. So go back and look at my chart. I know f prime will be positive or negative based on whether or not f is increasing or decreasing. So let's look at this. Let's see, looks like f, which I have values of f right here that I can see. Based on my chart, it looks like from negative 16 to negative 19 to negative 23 to negative 28, it looks like f is decreasing. Well, if f is decreasing, that tells me that the derivative is going to be negative. So I can know that it's not one of the first two options. So now I have to worry about the sign of the second derivative. Let's see, for the sign of the second derivative, I would need to know if the function is concave up or concave down. Now this can be tricky to figure out when you just have numbers. But if I had numbers for f prime, then I could tell if f prime was increasing or decreasing. So we're going to estimate f prime. Maybe I should change colors because now I'm working on f prime. Estimate values of f prime with the slope formula. Oh dear, with the slope formula. Okay, so I'm estimating values of f prime. So let me just make another chart. Now, because I only have random points in f of x, I don't know if this is exactly what happens, but this is why we have this could possibly be true. So if you don't have any other information, we can use the slope formula. So let me find the slope between these 2 points. I would need to take y2 minus y1, so negative 19 minus negative 16 over 5 minus 3, that's x2 minus x1. So f prime, maybe I should do f prime right here because that's the slope, which is f prime. Negative 19 minus 16, or minus negative 16, divided by 2 is negative 1.5. Yeah, divided by 2. Negative 1.5. Okay. Now let's calculate the slope between these 2 points. Negative 23 minus negative 19 over 7 minus 5. Let's see, negative 23 minus, I'm using a calculator right now. That's why I'm saying it over. Negative 4 divided by 2, I get negative 2. And then look at the slope right here. Negative 28 minus negative 23 over 7 minus 9. You get negative 2.5. So these are values for f prime. And it looks like f prime is decreasing because negative 5 decreases to negative 2. Negative 2 decreases to negative 2.5. So it looks like f prime is decreasing, which tells me that f double prime would also be negative. So I would choose this one. F prime is negative and f double prime is negative. Now we are looking for some more stuff to analyze. Okay, so I have given, there's geese outside, they're honking. That freaked me out for a minute. All right, given selected values of twice differentiable function f, which of the following could possibly be true? And this time I have to determine if f prime would be negative and increasing, or negative decreasing. So going back, I'm looking to see f prime would be negative or positive, so I can tell by f, and then I can tell if f prime is increasing or decreasing by f double prime maybe. Okay, so let's first of all figure out if f is, if f is increasing, f prime would be increasing, no, if f is negative or positive. Okay, well, it looks like f is negative 12 to negative 20 to negative 26 to negative 30. Looks like f is decreasing. So if f is decreasing, then that tells me f prime is negative. So I can eliminate these two. Now I need to figure out if f prime would be increasing or decreasing. So let's do slope. So we're going to use slope to estimate values for f prime. So between here and here, to get f prime, I need to do slope formula. So negative 20 minus negative 12 over 3 minus 2. Negative 8. Then I would do negative 26 minus negative 20 over 4 minus 3. I get negative 6. And then from there to there, negative 30 minus negative 26 over 5 minus 4. I'm getting 4. Negative 4. Negative 30 plus 26, negative 4. Yes, double checking. So it looks like f prime is decreasing. So it looks like f prime would be negative and decreasing. There we go. Then in this section, you'll also have to say what f prime of a number could be. So we won't exactly know what f prime is, but we can give a pretty good estimate. So let's get some values for f prime. Again, we're going to use the slope to estimate values of f prime. So let's see, from here to here, I'd do 17 minus 6 over negative 2 minus negative 3, which would be 11. And then from here to here, 47 minus 17 over 1 minus negative 2. I get 10. And then for the last interval, 55.5 minus 47 over 2 minus 1. $8.5. Okay, so what I have is I have pretty good estimates for f prime. So f prime from negative 3 to negative 2 is the average, it's about 11. From negative 2 to 1, f prime is about 10. From 1 to 2, f prime is about 8.5. But they're asking me what is f prime of 1. So f prime of 1 would be right in between these two intervals. So as long as you pick any number between 10 and 8.5, you'll be correct. So I entered 9 on mine, and it worked just fine. And then here we see that selected values of the twice differentiable function f are shown. Tells me f prime stays greater than 2. So the derivative is always going to be a number that's bigger than 2. And f double prime is always negative. So for all x on the interval from 3 to 18, which of the following could be a value of a? So notice there's a blank for a here. So what could a be? They're saying, could it be 71? Could it be 81? Could it be both? Well, let's do what we've been doing and just come up with values for f prime. So I'll go ahead and I'm going to pause and do those so you don't have to watch me calculate everything. And here's what happens when we calculate or we estimate values for the derivative on each interval. Looks like from here my derivative decreased. I also know that f double prime is negative. So remember, you're used to seeing this, f is concave up, f prime would be decreasing, f double prime would be negative. Okay, so when f prime is negative, then I know that f prime has to decrease. So I know that this number right here needs to be less than 4. So my f primes need to keep decreasing. I also must be less than 4. The other thing I know is that they told me that my derivative always stays greater than 0. Not greater than 0, greater than 2. So this information tells me that this number must be greater than 2. So I've got two options here. This could be a 71. So if we put 71 right here, let's see what happens. If this number is 71, then that means, I don't want my eraser to be too big. That means that I end up with 71 minus 62. I end up with 1.8. Well, 1.8 is less than 4, but it's not greater than 2. So 71, it can't be that number. Okay? So then let's try the 81. So what happens if this is 81? So I'd have 81 here. 81 minus 62. Divide that by 5, I get 3.8. Well, 3.8 is less than 4 and greater than 2. So 81 does make this work. So the only one that would make this true would be 81. Now let's talk about the intermediate value theorem. Intermediate value theorem is pretty huge in calculus. It's one of the existence theorems. So we use it to say that something exists. So there are some criteria that must be met, though. The first criteria is that f has to be continuous on a closed interval from a to b. So let me draw a sketch. So from a to b, f has to be a continuous function and closed interval. So the endpoints have to at least be closed and no holes, no asymptotes between a and b. Okay, so that has to be met. K is any number between f of a and f of b. So f of a and f of b are the y values. So this part would be f of a. This would be labeled f of b. K is some number in between. So I'm just going to pick any number right here. Let's say this right here is k. That's a y value. Then there is at least one number c on the interval from a to b. So there has to be a c somewhere between a and b, such that f of c is the same as k. What that is saying is that there has to be a place on this graph that has this y value, and that number has to fall in between a and b. So look what happens. If I trace this over to the graph, here it is. Hits the graph. So that means there has to exist this number c in between a and b that has this y value. So f of c is the same as k. So that's what that means. Here's how you'll be asked about it. Selected values of the function f are shown in the table below. Determine the validity of the statement. So we're given a statement. We've got a table, and we have to say if it must be true, must be false, or could be either true or false. So it's saying f of 0 has at least two solutions in the interval, the closed interval from -2 to 3. So -2 to 3 right here. Though it says y has to be 0 somewhere. So when I first look at this, I think, okay, well, the y values are negative and then they change to positive. So there could be a y value right here. And then the y values are positive, change to negative. So that graph could cross the x-axis right there as well. So has at least two solutions. Hey, that could be true. Maybe it is true. But in order for the intermediate value theorem to apply, some conditions have to be met. So first of all, f has to be continuous. Well, does this say that f is continuous? No, it does not. So this graph could have some holes. Like there could be a hole in between x equals -2 and -1. And so the graph would totally skip over 0. So we would just say the graph could either be true or false because not continuous. But then this one, notice it does tell me the function is continuous. Determine the validity of the following statement. So continuous on a to b. So it's continuous from, it looks like continuous always. It says f of x equals 0 has at least one solution from -3 to 0. Let's see. So I know it's continuous. The graph does change from negative to positive. Since the graph is continuous, you can't skip over any y value, so it does have to hit 0 at least one time right there. So this statement must be true. Now let's talk about the mean value theorem. You're going to need to see the whole thing. Mean value theorem deals with slope, the value of the slope of an entire interval, and the value of a derivative. So the criteria that has to be met. Function needs to be defined on the closed interval, and it needs to be differentiable, meaning that you can take the derivative. So the way that this looks graphically, differentiable means you have a nice smooth curve. There's no sharp points. No, like the absolute value graph has a V. The V has like a sharp point at the end. So differentiable means you have this nice smooth curve. Says there's at least one number c in the interval from a to b such that f prime of c equals, and this is the slope formula. So what this is saying is you have this section of a graph. So let's look at this one right here. Section of a graph from point A to point B. So what it says is if you find the slope between these 2 points, slope. Okay, so to find the slope, I have A, I need y value. So if this is x value A, then that y value would be f of A, and this y value would be f of B. Okay, so I find the slope of the whole thing, which is f of B minus f of A over B minus A. So the slope of the line between the endpoints. That's this part. As long as this function is continuous, the mean value theorem guarantees that there's at least one point on the curve whose tangent line has the same slope. So that's the f prime of c part. So there has to be at least one point where the derivative is equal to the slope between the 2 points. So let's look at this. Selected values of the function are shown in the table below. The function is continuous on the closed interval, which is one thing that has to happen. Check. And differentiable on the open interval, so that part is checked. So the mean value theorem does apply. Determine the validity of the statement. So does there have to be a c in the open interval from -3 to 3? So there has to be a c somewhere here, such that f prime of c would be -5. So is there a c somewhere? So that c, because I've only got 3 options, the c would either have to be right here, or either one of these, where f prime of c would equal -5. Okay, well, first of all, let's find the slope of the entire thing. So let's find the slope from here to here. So I would do the slope from here to here. So I would do -23 minus 4 over 3 minus -3. Which is 19 over, -23 minus 4. Sorry. -27. Over 6. I'm getting -4.5. Okay, well, the slope between the 2 endpoints is -4.5, which is not -5, but maybe there's another place where the slope would be equal to the -5. So let's check the slope right here. So I would do -11 minus 4 over 0 minus -3. That would be -15 over 3, which is -5. Hey, which is the same as that. Okay, so what this is saying is that since the slope from -3 to 0 is -5, then there has to be another x value in here that's slope would also be -5 because all of the other criteria are met. So we would say this statement must be true. Now, algebraically to do this, we're going to go to delta math. And I think this does a really good example of showing you exactly what the mean value theorem is saying. So here, and this is one where we have to find C2. So we're given that the function f of x equals x cubed minus x squared minus 17x plus 5 is graphed below. We're going to plot a line segment connecting the points on f where x equals -4 and x equals 4. So x equals -4 is this point right there. Oh, they already have it kind of, tell me where to click. And then x equals 4 is this point right there. Okay. Afterwards, determine the values of c which satisfy the conclusion of the mean value theorem for f on the closed interval from -4 to 4. So I plotted it. So now I'm going to work on, so really that tells me I'm only interested in this part. Let's see if I can highlight is good. I'm only interested in this part of the function because that's where I plotted my curve and that's where it hits. So I'm only interested in this green part. So because this curve is continuous and differentiable on this green part, and we've calculated the slope from this end to that end. The mean value theorem says that there has to be at least one other point that would have the same slope. The derivative would have the same slope. So I think of like if I draw tangent lines here, see how those slopes are different from the one that got plotted? But if I look at, let's see, I'm trying to draw one, maybe right here. I'm thinking there might be one right there. And I'm thinking anywhere else? Maybe something around here. Looks like it might happen twice where that slope would be parallel. That might happen. So I have to find the x values, which I have a good guess. I think it might be in between -2 and -1, and maybe in between 1 and 3, somewhere in there. But I'm going to find them more specifically. So I'm going to find the x values that have tangent lines. In other words, the derivative. With the slope equal to the slope of this green line. So let's calculate the slope of this green line. So this is at the point, it's kind of hard to see what that point is. I need those coordinates, don't I? Well, it looks like it's at, this point is -4 something. And this point is at 4 something. But I can't really see those y values. So you know what I can do? I can go to the formula and substitute in -4 for all the x's to get this y value. And then I'll substitute in 4. So if I substitute in -4, let's see what we get. So substitute in -4, we get -7. And now let's substitute in 4. Substitute in 4, I get -15. So now let's calculate the slope of this green line. So m would be -15. Whoa, let's try that again. Minus -7 over 4 minus -4. Which is -8 over 8. So the slope of that green line equals -1. So this slope is -1. All right, so I'm trying to find the x values that have tangent lines with slopes equal to -1. So I'm guessing right here these slopes are -1, but I need to figure that out. Well, the tangent lines are the derivative. So I need to find the x's where f prime equals -1. So I need to figure that out. So first of all, I need f prime. So let's come up with f prime. F prime equals 3x squared minus 2x minus 17. I'm going to set that equal to -1, which again is the slope of this green line. So -1 equals 3x squared minus 2x minus 17. I'm going to try to solve it by factoring. So if I add 1 to both sides, I get 3x squared minus 2x minus 16. And then I'm going to try to factor. So it looks like if factor 0 equals 3x minus 8 times x plus 2. If I set each one of these equal to 0, I get that x equals -2, 3x equals 8, x is 8/3, and because I'm looking at the graph, x is approximately 8 divided by 3, 2.6 repeating. So hey, we said that it looked like that was happening at x equals -2, which is right here. Hey, so I know f prime of -2 equals -1. And then it was also happening at 2.6, which is right there. F prime of 8/3 equals -1. So the question is, find all the values of c, which are the x values I just find, between -4 and 4. So both of these are between -4 and 4. So I will enter them both. -2 and 8/3. We got it. So that's what you'll have to do for this lesson. Have fun. Once you do this, you will have just finished our 4th unit. So congratulations on finishing the unit. We will review next class. Have a great day.